What I like to do today is to see how you did on this worksheet. So I'm going to work a few of the problems and see how you can check your papers and see how you made out. Number one, and then we'll do the first worksheet. Number one, log base 7, 49. Okay, you rewrite 7, and we're looking for the answer. To what power is 49? And we change 49 to 7, and that's 7 squared. So the first problem should have had equal 2. That should be the answer to number 1. Now let's go to number 2. Log base 3, 81. Okay, we're looking for an answer. So we'd say 3 to what power is 81? Remember to write the base, and this is the power of the base, equals 81. Now we'll have to change 81 to a power of 3. Well, that's 3 times 3, that's 9, times 3, that's 27. Times 3, that's 81. So we would have 3 to the power of x is equal to 3 to the 4th power, and then x would equal 4. Now I'm going to leave number 3 for you to continue to try to attempt, or if you have it already, you'll know that number 3 has an answer of 6. Let's go to the next row. Number 4. It goes log base 2. Now we have a rational number. Okay, we're looking for what x is. So you say 2 to what power is 1/4. Now we've got to change 1/4, so it's not 1/4, but a 4. So that's 4 to the negative 1 power. Now we change 4 to a power of 2. So it'll be 2 to what power? Now, you know that 4 is 2 squared. Okay? Then you would take in a power, raising it to a power, you multiply. So that's 2 to the negative 2 power. So x is negative 2. Next, number 5. Log base 5, 1/125. Again, we're looking for x, so that'll be rewritten as 5 to what power is equal to 1/125. We need to get this changed to 125 to the negative 1 power. So 5 to what power is equal to, now 5 to the 3rd power is 125 to the negative 1. So then you take and multiply these powers, so that'll be 5 to the negative 3 power. So x is equal to negative 3. Now I'm going to leave you to continue to work with number 6. Number 6 has an answer of negative 4. So see what you get. Now let's move on down to the next one. Number 7. Log base 5, square root of 125. Now we're looking for the answer. Now remember, this is the base. 5 to what power is equal to the square root of 125. Now with logarithms, we can't use to have the radical sign, so we rewrite that as 125. Now I hope you remember that's to the 1/2 power. So 5 to what power? Now, change 125 to a power of 3. That would be 5 times 5 times 5, which is 5 cubed to the 1/2 power. Now you need to multiply the power, so it'll be 5 to the 3/2. Now, so x is 3/2. We'll change that to a mixed number, so the x is 3/2 is equal to 1 1/2. Alright, let's do number 8. Log base 2. Now this is the 5th root of 16. Now we're looking for an answer. So you'd say 2 to what power is the 5th root of 16. Now we would write 16. Now the 5th root is something raised to the 1/5 power. So you have 2 to what power is equal to, now change 16 to a power of 2. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's 4th power. And you have that to the 1/5. Now multiply your powers, so it'll be 2 to the 4/5. Then x is 4/5. Now again, I'm going to let you to continue on with number 9. Now the answer to number 9 would be 3/4. Now, when you get to number 10, number 10 is what we accomplished earlier in the year. So, truthfully, I would not have 10 here. I'd have had it earlier, but it was already on my worksheet, and I decided I'm going to leave it, and it doesn't hurt to spend a little bit of time reviewing. So, here we go. Now the base this time is our unknown. So we're going to say the b, that's the base. Now 4 is the power of the base, equals 81. Now you could look at this a few different ways to get this answer, but what we want to know is what number times itself 4 times is 81. So if you start with thinking 2 times itself 4 times, that would be 16. Obviously, that's not what it is. But if you go 3 times itself 4 times, you'll see that that's 81. So, what number times itself 4 times is 81? The answer is 4. I'm sorry, 3. And that would be how you do number 10. Now let's see if number 11 would be any easier now. Log base 5, base b. 32 equals 5. So that would be b, base first, and 5 is the power, equals 32. So now we're asking yourself, what number times itself 5 times is 32? And if you go through the process, you will figure that out, that b is equal to 2. Now we've already accomplished that problem early in the year, but I thought maybe you could see it. Now I'll leave number 12 is not like number 11, so let's do number 12. Now, 12. You have the log of base b, 1/9 equals -2. Well, that's b to the -2 power is equal to 1/2 9. Now, young people, this one here is a little bit different strategy, you might call it. You got to have b to the first power. So the question is, and this is how we did it earlier, what would you multiply negative 2 by to get positive 1? Well, the answer would be negative 1/2. What you do to one side, you would have to come over here and multiply this to the power of negative 1/2. So this answer, of course, is 1, but if you remember correctly, we did this, like I said earlier, the bottom number means the root value, top number is the power, and the negative does not change it to a negative answer, it inverts the answer. So you do all three of them at one time. You ask yourself, what's the square root of 1/9? What is 1/9? Well, obviously the answer is 1/3. Raised to the power of 1, that's still 1/3. And then you invert 1/3, and the answer is 3. And that's how you accomplish number 12. Now, number 13 is kind of like that one. So it's a log base b, don't know the base, 1 over 125 equals negative 3. Again, this is the power, 1/3, negative 3 is the power. So you go base to the power of negative 3 is equal to 1 over 125. Now we want b raised to the first power, so what would you multiply a negative 3 by? So the answer is 1. The answer is negative 1/3, because a negative times negative is positive, and 1/3 of 3 is 1. Well, what you do to one side, you must multiply the other side, or take it to the power of negative. The bottom number again, root. Top number, power. Negative does not change it to a negative answer. It means to invert your answer. So I start off with the root. Now what time itself 3 times is 1 over 125. Obviously the answer is 1/5. To the first power. Again, 1/5. Inverted. I answer 1 over 5 becomes inverted 5. And that's how you do number 13. Now I'm going to leave number 14 and number 15 for you. Now, the answer to number 14 is 2, and the answer to number 15 is 4. So you can check your work and see how you did. Now, on the worksheet, we move into the next section where we're solving where you cannot change the base to a powers that are equal. So new number 1, log base 5, 3. Okay, that's 5. We're looking for an answer to what power is 3. Now remember, we're going to use Mr. Napier's logarithms here. Now he said if you'll take the log of the numbers, but remember what I told you yesterday. Remember, this is what you got to remember when we're doing the rest of these problems, that he said if you take the logarithm of a number to a power, you are to say the power times the log of the number. So over here we would say x times the log of 5 is equal to the log of 3. Divide by log of 5. Log of 5. Now go to the calculator and get the answer. You would say log on your calculator. You push the button that says log. It'll open parentheses. You be certain to close that parentheses around that number before you divide. Then it's log, and it'll open up. If it doesn't have a parentheses open there, you place a parentheses, and then 5, and close it up. Now the answer for number 1 should be 0.683, and be certain you put a decimal, or a dot rather, over equal. What that means that your answer is approximately that answer. It's not an exact answer though. Okay, that's number 1. Now let's go to number 2 in this section. Log base 4 9 equals, well, we like to know what it equals. So you put 4 to, now people, that's debatable. We're going to keep on going and continue this problem. Equals 9. So we're going to use Mr. Napier's logs. Log. Log. So you would, now don't forget you're taking the log of a number to a power, so it'll be x log 4 equals log 9. Divide by log 4, log 4, and now it's the calculator time. You would say the log of 9, and then be sure to put it in parentheses. I'll do it one more time for you. Log, now put 9 in parentheses, divided by log 4, and the answer to number 2 is approximately 1.585. That's number 2. Now I'm going to leave number 3 for you and number 4 for you. Now number 3's answer is 2.226. Number 4's answer is 22.517. Now number 5 is where we would use this in case you were solving for x in a problem. And the x is a power. So we want to know, what does that x represent? Again, we're going to incorporate Mr. Napier's logarithm. So you'd say log, log, and that's the power. Remember what he said, 2x minus 1. You take the power times the log of the number equals the log of 7.65. Now, we want to solve for x. We want to know what x equals. Now, there's only one x, so we'll do it by elimination. Log 4, log 4. So we'd have 2x minus 1 equals. Now, you put that in your calculator. That's the tardy bell. We already hear. Log 7.65. Now be certain that you have the number 7.65 in parentheses. Log of 4 equals. And that we we don't write that answer down because we've got to continue on over here. Now remember, I do not want to round that off, neither. I want to leave it on the calculator. Do not put that on your calculator. Leave it. Now, because we're not finished solving for x. Because the next thing you need to do is to add 1. So simply take your calculator with the previous answer on it and add 1 to it. Now, again, you're going to have that answer on your calculator. Don't round that off yet because we're not finished with solving for x. You got to divide by 2. Now, after you have accomplished that, you are now ready to round it off, and the answer to number 5 is approximately 1.234. And that's how you do number 5. Now, number 6 is the same setup. 8 to the power of x minus 3 equals 25. So, we use Mr. Napier's log. We want to solve for x. We want to know what that x equals. So, we'd say the log, and now on both sides. So, it would be x, the power, times the log of the number, is equal to the log of 25. Divide both sides by the log of 8. So you have x minus 3 equals, now remember we just put our answer. Now I'm going to let you determine what that answer is. I'm not going to write it on the side. You put log 25 in parentheses divided by log 8 in parentheses. Now, don't round that answer off yet because we have not solved for x yet. So we got to add 3. So add 3 to that answer, and now we got x equals, then we'll solve for that, and that's number 6. And the answer that I have is approximately 4.548. Now that's number 6. Now I'm going to leave you with number 7 to do again by yourself, and that's going to be negative 0.076, and number 8 is 2.378. Now I'm going to do number 9 next. Okay, let's look at number 9. 2 to what power is 3 to the 2x plus 1? Now notice the 2 and the 3, you can't change 3 to a power of 2 nor 2 to a power of 3. So we're going to use what we've been talking about, Mr. Napier's logs. So you would say the power times the log of the number equals, the power is now, if you rewrite two things, you need to understand to put them in parentheses so they'll stay together. So you need to put 2x plus 1 in parentheses. Now what makes number 9 different from number 6? We have 2 x's. And to do this, we're going to have to distribute. Not on the left side, of course, but on the right side. So you'd have x log 2 equals, now we're going to say 2x times the log of 3 plus, well, 1 times anything is just be log of 3, even though we're distributing. Now, what you need to visualize here and realize that you have, again, 2 x's on opposite sides of the equinox. In mathematics, you cannot have that. You can only have the 1. So one of them is going to be what we call eliminated. Now, I'm going to do this one on the left side. Well, of course, you got to do what you do to one side. But notice that this is the log of 2 and this is the log of 3, which means you cannot subtract anything. It'd be like that's x, that 2 is an x and the 3 is a y. You can subtract unlike terms. Well, those are classified as unlike terms. So what you would do, I would put the plus one first. So it would be log x times log of 2 minus 2x log of 3. Now, that cancels. So we have equals log of 3. Now, this is where I told you yesterday, I tried to tell you yesterday, is that if you can get over this particular spot here, and remember, let your mind remember it, to factor out the x. Not the common factor or anything, x. What that indicates or what that requires is if you would say x times log of 2 minus 2 log of 3 equals log of 3. Now, to solve for x, we would divide log 2 times log 3. What's due to one side? So it'll be log 2 minus 2 log 3. Now, how do you put this on your calculator? Now this is, I'm going to bring it down to the bottom here. You would say log. Now be sure you put 3 in parentheses, divided by log 2 minus 2 log 3. Now be sure 2 is in parentheses and 3 is in parentheses. Be sure you write that. And so you would then hit equals and approximately negative 0.730. And like I said, if you can get over the hump here, up here with this star, then where we have to factor out the x, I feel comfortable that you can accomplish that problem. Now, of course, that's number 9. What I would like to do is number 10. Next, number 10. A little bit more of a challenge. Let's see if we can accomplish it. 5 to the power of x minus 2 equals 6 to the power of 2x plus 3. Using logarithms. Now, so you take the power times the log of 5 equals the power times the log of 6. Now, you have seen this, and I've mentioned it to you. You got x's on both sides. When we have an x on both sides like that, we have to distribute. So it would be x log 5 minus 2 log 5 equals 2x log 6 and plus 3 log 6. As you'll look, we have x's again on both sides of the equal marks. You cannot have x's on both sides of the equal mark. So we're going to eliminate one of them. And I always do the one on the right. Even though it's a negative, I can still work with it. Now, because of the fact that this is the log of 5 and this is the log of 6, you're not going to be actually to be subtracting these. So you would write x log 5 minus 2x log 6. Now, if you look up here, this does not have an x. So we don't want them to stay over here with my x's. So what we're going to do is add 2 times log 5 to both sides. Now, of course, that canceled earlier. And so we have 3 log 6 plus 2 log 5. Now, here we go with that star again. Here's where the problem makes it a little bit of a challenge. We have an x and an x, and we need to factor out the x. Now, if you can recall that, if you make sure you pay attention to that, you're going to get the right answer every time. I just feel so comfortable with that, confident. But if you fail to factor out the common factor of an x, then this would be a difficult problem or challenge that we have to say on to. So you'd have x log 5 minus 2 log 6 equals 3 log 6 plus 2 log 5. Now, a lot of times when people are working this problem, when you reach this point, they get tired and give up. Let's see how far we're going to go here. We're going to go all the way to the end. So you divide by log of 5 minus 2 log of 6. Of course, quite naturally, if you do it to the left side of the equal marks, you got to divide the right side. And that's log of 5 minus 2 log of 6. Of course, that cancels. Now, calculator time. Okay, all of this has got to be placed in your calculator. But first of all, we're going to start out by putting a parentheses for in front of that 3. So you write parentheses, then inside of it you would write 3 log. Now be sure on your calculator you put 6 in parentheses. If your calculator opens one, you got to close it before you can put the plus. 2 log. Now 5 has got to go in parentheses. But we open this first one. Okay, so what you're going to have to do is close that parentheses. So we have one in the front, and we have a parentheses in the front, and this one here closes it in the back. And inside of it you have the problem. Now, divided by the denominator. Now, it starts off with a parentheses, log. Now be sure when you put log on your calculator, it's going to open it up, and you put 5 and you close it. Be sure you close that parentheses. I'm emphasizing it enough that you probably won't forget it. So then you have 2 log 6. Now we bring in this parentheses down. So it ends with 2 parentheses. If you don't have 2 parentheses at the end of your calculator, chances are you're going to see a wrong answer. So if you did if you wrote all of this in your calculator, if you placed it in there just like I have it on this board, then you're going to have, my answer was approximately negative 4.353. Now people, that's number 10. Now if you look at my worksheet, number 11 and number 12, I'm going to leave for you to do. Try to continue. And if you're looking at the sheet there, number 13. Oh, by the way, number 11's answer is 1.482. Number 12's answer is negative 3.819. Now number 13 is like with every math teacher, they always want to see how far up the ladder you can go. Can you go to the top of the ladder? So number 13, I'm going to leave that as a challenge for you to do. See if you can work without any assistance, because that problem has a little bit more to do. You know that fourth root has to deal with that first. Are you sure of that? But if you try it and you want to know if the answer is right or wrong, it's 1.621. Now we got analogs. Now I tried to show you that, but I'm not going to be able or try to do all of the analogs. I'm going to do number 1. Now analog is the reverse of base 3, negative 2. Now this is where the 3 is the base. But now the negative 2 on analogs, now you got to understand this is for analogs, would be the power. So it's 3 to the negative 2 power. Well, the 2 means the square, but what does that negative exponent mean? Is to invert your answer. So if you square 3, that's 9, and invert it is 1/9. Now that's number 1. Excuse me. Number 5. Analog. Now let's see, the base is a rational number. And let's see if we can accomplish it. And 2/3. Now one more time. Analogs. Be sure it's analogs. This is the base. Still base. But this 2/3 is the power. And so that's 2/3 power. Now, don't forget, the bottom number is the root value. Now, the top number is the power. Now, our number is 8 over 64. Now, everybody should know that 2 times itself 3 times is 8. And 4 times itself 3 times is 64. So if I ask this question, what is the cube root of 8 over 64, your answer would be 2 over 4. But this 2 up here means to square that. Now that means you take 2 over 4 and square it. Well, that's 4 over 16. And everybody knows that if you simplify 4 over 16, the answer is 1/4. Now I'm going to leave the rest of them for you to do, but I will tell you the answer if you're listening. You can write these down as I say them. Number 2, 32. Number 3, 1 over 27. Number 4, 1/25. Number 6 is a mixed number, 2 and 7/9. Number 7, 1/8. And number 8 is 8. Now people, that's the first worksheet that we did, and I hope you have succeeded with it and get a right answer. Now on the back, or the second worksheet, is 11 problems. I want you to accomplish those 11 problems by yourself. Now that concludes this video.